All right. Okay, we're in our last section, and the second day of 4.6, we're working on coming up with the equations of a line, or the equations that represent a linear relationship. I have these x values and the stuff I do to it. What y value does that equal, or what does it add up to? And so let's just start with a little review of our techniques so far. All right. And here's the one I said, here's the one that's kind of the easy one. If we are working eventually almost with all of our equations at this point, we want to get into the slope-intercept form for a final answer. All right, you'll notice homework questions ask you to do that. I know some of you have been here more than others, so if I sound like I'm repeating a lot myself, it's just because I'm kind of reviewing as we go. Here, this is that shape that we call the slope-intercept form, where that number m that's multiplying the variable x is the slope or the rate of change. If I put something in, how much is it affected? And then b is that y-intercept value, that is our slope and our intercept are in that shape. Okay, so if I'm given that very specific information, you know, a slope value and a y-intercept value, and again, I'll emphasize that means x is 0. We're somewhere on the y-axis. I'm given a y-intercept, I can write the equation by directly plugging those values into that mold. This is one, I think you might see it in a test someplace just because it's hard to say, ask questions without talking about it, but you should know that form. Y equals mx plus b. You should know that one. So here I would say y equals 2/3 x plus the y-intercept value of 4. And there is the equation of the line with that slope and that y-intercept. Okay. If it's a negative slope, well, we put a negative number there for the m. Maybe the y-intercept was something like -2, so I'd probably write -2 over here. All right, y equals -3/5 minus 2, or something like that if I had a negative y-intercept value. All right, so that was, again, what I call the easy one. I rarely use the term, but hopefully if you get that information, you need to know what to do with that. Plug it right in. All right. From there, we went to, well, what if I know a slope and some other point that's not the y-intercept? And let me do myself a favor and say, oh, how about what if I know a slope value and some other point out in the middle somewhere, right? I know the slope. Recall that if I know where that point is, like 8,2 is up here someplace, and I know a slope, I should be able to start from that point and I could count the slope values and find a second point and graph it, right? But I want to come up with that equation. Every time we're trying to come up with an equation, we need a slope and a point value to work with. This time the point is not the y-intercept. Here comes Tara. Okay, we got her in there. All right, we need a point and a y-intercept. Excuse me, we need a slope and a point. Wrote it. So there was that point slope formula that I presented last time, but the method that I emphasize is called solving for b. You won't find it in your text. Probably, Google it or something if you needed more help with that. So here's a slope value and an x and a y value that should all work together in one equation. So if I put in these values for x and y, here's my y value, here's my slope value, here's my x value for this point that goes with that y value. I'll write it like this because I'm multiplying times that fraction. And then What I don't know, though, is the y-intercept. So if I plug in the slope and the x and y values, now I can solve this equation for the b, the y-intercept value, right? So this 2 is not doing anything yet. Let's simplify. How about I cancel a 4 out of those, right? So now I get 6 plus b. Solve for the b. I'm going to subtract the 6 from both sides. Negative 4 would be my b value, or that means 0, negative 4 is the y-intercept. Careful, problems will often ask you to express it as an ordered pair. Got to write it like that. Okay. So final answer though, now I found the y-intercept. Now I've got to go back and plug it into the slope-intercept mold there. So 3/4 x minus 4. So we did a fair number of examples, just ones with messier numbers last time, where I have a few too many fractions, but plugging in the slope, plugging in the y and the x, and solve for the b so that we could come up with our slope-intercept form eventually. All right. Then, well, stepped it up a notch, you might say. What if I don't know the slope, but I know 2 points that are on that line? Right? I still want to come up with this equation. I need this information. I need to know the slope. This was the extra step. You have to calculate the slope yourself. I expect that you know the slope formula. Right? The difference in y's, just real quickly, right? Rise means, what's the difference in the up and down the y values? How much did the y value change? Run, rise over run. That's that mnemonic phrase intended to help you remember. Run, what was the horizontal or x value change? So that formula, difference in the y's divided by, right? The rise is the difference in the y values and the difference in the x values on the bottom. Important in that setup, notice I call these sub 2. Doesn't matter which one, it's 1 or 2, but if I choose this y from this point, I have to choose the x from that point in the beginning here. So those have to come from the same point, and those have to come from the same point. And so now I can plug them in. Let's say 5 minus 1 for my y's, huh? And since I started here, I'll have to say 2 minus 3 for my x's. Do the calculation. 4 over negative 1, I'd say a negative 4 is my slope. And I like to write it as that fraction so I can still see the rise over the run when I use it. So that's the extra step. If I know 2 points but no slope, I have to calculate the slope first myself. Now, I can go back to that previous operation and solve for b. So I can pick either one of these points and it'll work out. Okay? So let's say 1 for y. I'm going to use this point. Make sure I use x and y from the same point. 1 equals negative 4 is my slope times 3 is my x plus b. There's my y, there's the x I used, and I used the slope I calculated. Now I can say 1 is negative 12 plus b. Solving for b, I'll add the 12 to both sides. 13. I have a y-intercept value of 13. There it is as an ordered pair. I've got now a slope I calculated, an intercept I calculated. Plug them in. plus 13. Notice, when we go back to that final step, we're putting in you might say the blank x and y right here again. We're just using the slope and the y-intercept that we calculated. This now is an equation that we could use, put in any x value to find any other point that is on the line that goes through those 2 points. Okay? You could use this equation models the relationship for that line, all the points on that line. Okay, so that was a little quick 1, 2, 3 different kinds of things that we've done so far. All right. Is that okay? As always, I say, should we back up a minute? Want to review something? We're going to really continue with much of the same material, but different context now. Okay, here goes. Yeah. Well, in the previous section, that is 4.5, we discussed recognizing lines or equations of lines that were parallel to each other and equations of lines that were perpendicular to each other. What's the deal with parallel lines? They've got the same slope. Hopefully that makes a lot of sense just intuitively. Parallel lines have the same slope. So what if I have the equation of a certain line? Here we go. New step today, right? Y equals 3x plus 4. There's a certain line. I would like the equation of a line that's parallel to that one. And let's make it go through the point 6, 5. Okay, I want it to go through that point. So that's nice. I've got an equation for one line, but I want to write a brand new equation using this point. I need a slope and a point. What's the deal? If it's parallel, I know it's got to have the same slope as this. So for these kinds of problems, all you want to do is pull out the slope value. If it's going to be parallel, I know it's got to have a slope of 3. And that's all I do with this equation now. I'm done with that one. Don't try to mix them together or something like that. See it all, right? But now I have a slope and a point, and I'm doing what we did a minute ago. And I'll come up with the equation of another line through this point, this slope, and just happens to have that be parallel to that one. So what am I going to do? I'm going to solve for b with this one. So y is a 5, slope 3 times 6 for my x plus a b, right? I'm not doing anything with that equation. Just back to that other process now. And so, all right, subtract that 18. Negative 13. There's my y-intercept. I knew the slope from this given line. Now I calculated my y-intercept, so the equation of the line parallel to that, going through that point, 3x, right? What's different? It's this y-intercept. If it had the same y-intercept, if I pick some dumb numbers for my examples, if it's the same y-intercept, it's the same line. So, but the fact that they're parallel, different intercepts, excuse me, same slope, different intercepts means they're parallel. Two brains working at once here. All right. One example. Let's do it again. All right. Get rid of that, right? And let's try. Whoops. Let's mix this again. Well, parallel to this line. I want it parallel to this line, but going through that point. Okay. Parallel means it has to have the same slope. So I can see from this equation what the slope of this line is, 2/5. So that is the slope I'm going to use now for my new equation. Some of the text problems that we might have done in terms past, if we were in the classroom or did more homework out of our textbooks, might mix up this equation, so you actually have to rearrange it to see what the slope is. Yeah, we're going to just practice this technique. You've got to recognize what to do. If you see the slope there, we want to use that slope. But now I've got a slope to work with and a point to work with, and I'm going to use my solve for b again. So let's say my y value of -3 now equals 2/5 times 10 is the x value plus b. Not doing anything with that equation anymore. And let's cancel some 5s here. -3 equals 4 plus b. Subtract the 4. B is -7. 0, -7 is my y-intercept. So that means y equals 2/5 is the slope I'm using. And did I? Steve, you did it. I said, if I pick some dumb numbers for my example, I got the same line, didn't I? But the process, so hopefully that makes sense. You understand the process. All right, they both have -7. How could I do that? Just pick some number out of the blue. I was looking at my examples here. It's like, I don't like that one. I'm going to make up one with a fraction. Of course, I picked a fraction, and I picked a 10 to go with the fraction. All I needed was a different number there for y. It would have worked out nicer. We better do that again. Hopefully that makes sense, though, the process, right? Pull out the slope, use the point, solve for b. And we got unlucky. Turned out to be the same line. What are the odds? Ah. Here's another one, okay? And 12/2. Cross your fingers, Steve. Let's make it parallel to that and through that point. First thing you got to say is, oh, what's the slope? I know a point. I need a slope and a point. What's the slope I'm going to use? Oh, there it is. -3/4. That's the slope I'm going to use. All right, let's solve this for b. Huh? Starting over. Y is 2, -3/4 times 12 plus b. All right. Like that makes sense, right? And 2 equals -9 plus b. All right, -3 was still here, times 3. Let's add the 9. 11 is my intercept value, 0, 11. So y equals -3/4 x plus 11. Two lines, same slope, different intercepts, they're parallel. Okay, here goes. Let me erase that. most of it. I'm actually going to leave that equation in that point. What was the other special relationship? How about perpendicular? I like the equation of a line. I don't know why, but for some reason. The equation of a line that's perpendicular to this one and goes through that point. You just think whatever this line is over here, you know, I can be perpendicular here, I can be perpendicular here, right? Into a number of possible perpendicular lines, but it's got to go through that point. One out here someplace. Well, so what was special about the slopes? Again, it's all about the slopes of perpendicular lines. And here's what I have to recall. There's two changes. There's two different conditions. Right? It's not just enough to be positive and negatives, because those are both about 1/2 and -1/2, but they're not perpendicular. They have to have opposite signs, but they are also reciprocals of each other. So there's the question, what slope do I need to use? Perpendicular slopes are negative reciprocals of each other. Now we use the word negative meaning opposite, opposite of what it was, the negative of the negative. This could be positive, right? So opposite signs and reciprocals. Opposite sign means this one's going to be positive. Reciprocal means 4/3. There's the new slope I'm going to use. Now, just like the parallel situation, I'm done with that equation. I'm not going to try to do anything more with the original one. I just needed to get the slope to use based on that first one. Back to solving for B. So here we go again. How about 2 equals this new slope now? 4/3 times my x value plus b. Okay. And let's cancel some 3's here before I multiply, okay? 2 now equals 16. See? All right, 4 times 4. Subtract the 16. -14 is my y-intercept value for this perpendicular line. Now, when I'm writing my equation for that perpendicular, make sure you use the new slope, right? I have to use its perpendicular slope now. 4/3. And what did we come up with? -14, -14. So you got to be able to look at those and say, oh yeah, opposite signs and the reciprocals of each other. Remember that other condition that if you were to just check it out, if you were to multiply those two slopes together, the first one and the second one, they always kind of cancel out except they leave -1, right? The 4's are canceled, the 3's are canceled, but you still have -1. Negative reciprocals, or they multiply to -1. Do that again, okay? Perpendicular to. Yeah, how about this? Uh-oh. There's one of those that's in that standard form. The x's and the y's are on one side, equals some number, and those y on the other side. I want a perpendicular to this line, but through that point. I can't just look at this right now and know what the slope is. I'm going to rearrange it so I can tell what the slope is. I'm going to solve it for y. Well, I'm adding a little extra wriggle here in this example. So let's see. I'm going to leave the y's and I'm going to subtract the x's. Okay. So that leaves a negative sign. Don't lose that negative sign there. It's in front of the y term, huh? Negative 3y equals negative 4x plus 5. Just because we're heading for this shape, I put the x's first. Now I'm going to divide by that negative 3 every piece. Now, it won't affect us much because we're going to write a new equation in a minute. But, you know, if you were solving for y, you'd have to divide every piece by that number. Negative, negative gets me positive. Here, minus 5/3. Negative 5/3. Now, this is just a coincidence that it looks like I have a similar slope as my first example when I pulled off my sheet of problems here. But now, all that work was just to get it in this shape so I could figure out what slope to use for perpendicular. So, what would that be? Think for yourself right now. It needs to change in two different ways. Opposite sign and reciprocal. So positive will turn negative and 3/4. Negative 3/4 now is going to be the slope to use. Looks like I'm going to get some fractions maybe out of this problem. All right, so here we go. Solving for b again, right? Solving for b. 2, my y value. Make sure you start from y. New slope, negative 3/4 times negative 3 for my x value, yeah, plus b. All right, I did a real good job here. I'm going to get some fractions. Nothing to cancel, right? 2 equals negative negative is 9/4 plus b. I'm going to have to subtract that 9/4 from both sides. You still see me down? Oh, yeah. No problem. Now, common denominator, 2 minus 9/4. 2 over 1, if I do 4 times 4 over 4, I'll get 8/4. Everybody okay with that? 8/4 is the same as 2. All right, if I had 2 over 1, I could get a common denominator by multiplying by 4 over 4. 8/4. 8/4 minus the 9/4 will equal my b. Negative 1/4. I did a lot of stuff there. Make sure I didn't mess up anywhere, right? Negative 1/4 is going to be my y-intercept. All right, got to go back and write that final equation. It'll always ask for this slope-intercept form, even though it might have started out in this other standard form here. So, got to remember to use the new slope and this intercept. Negative 3/4. There, final answer. Right? You're up. Out of the blue, completely different question. Write the equation of a horizontal line through that point. Right? 6, negative 2. 1, 2, 3, 4, 5, 6, negative 2 here. Here's this point down here. What's the equation of a horizontal line that goes through that point? Oh my gosh, what do I need? Well, you can figure out, well, it has a slope of 0. But we tried to recognize this type as like a special situation. If it's horizontal, what's consistent? Y is always negative 2. Y is always negative 2. Right? that horizontal line. Equation of a horizontal line through that point. Y equals -2. That's all you need to say. What's the equation of a vertical line through that point? All right. Vertical line. It's going through that point. What's always consistent? Missed. All right. No matter what y value, x is always 6. X is 6, x is 6, x is 6. Vertical line. That's all you need. X equals 6. All right. Let's say I've got that horizontal line, y equals -2. Can you write the equation of a vertical line that's parallel to that? Back up, I was thinking perpendicular, so erase that. Let's write the equation of the line that's parallel to that and goes through this point. Parallel. Parallel to this one and goes through that point. Draw yourself a picture if necessary. Here's the one I gave you. I want to go through that point and be parallel to this. See, that point's out here, 1, 2, 3, 4, 5, -4 or 5, 4, okay. Somewhere up here. What's parallel to that? It goes through that point. What's the deal with horizontal? First, you have to recognize that's a horizontal line. All right, that's horizontal. I want a horizontal line through that point. What's the equation of a horizontal line through that point? It's always got to have a y value of 4. I have a horizontal line and I recognize it's a horizontal line. If I'm going through some other point horizontally, all I need to know is what its y value is. Okay. The other question I started to ask, what would be the equation of the perpendicular line to that one through that point? Oh, perpendicular to this one through this point. Perpendicular, oh, that's the vertical, right? If it's going through that point, what's always the same is the x value. Vertical is the x value is always the same. Horizontal, the y value is always the same. Y value is always the same. So we can, throw in the parallel and perpendicular questions when dealing with horizontal and vertical also. Try to remember those special forms. Last Thursday, in the middle of our class, my furnace repairman showed up. And let's say that company is charging me a $50 fee for him to show up and check things out. And if he has to work for any period of time, they're going to charge me $40 per hour. Can you write an equation that describes the cost in terms of the number of hours this person might work? That really means the y is the cost, right? And what's the part that varies or changes is the number of hours. Now, what kind of information did I give you? If he shows up and doesn't do anything, what's it going to cost me? $50 just for showing up? If he shows up and doesn't do anything, $50. Get my point? Y-intercept. I know, dumb old guy jokes, dad jokes. My point is, right, that's your y-intercept. What's this? $40 per hour. That per, like miles per hour, that's almost a clue. That's the slope. It's a rate of change, right? Oh, I have a y-intercept and a slope, right? So I could say the cost is, here's like those examples I showed you. Maybe I'd say I've got a fixed $50 fee, but then it's $40 for every hour. Now it's like B plus MX. Doesn't matter. All right, there's more typical form we talk about. Probably should look a lot like homework problem that's due tonight, handed homework, right? Now, if it actually is a word problem, they might go on and say, well, if he works for 3 hours, what's it going to cost? 3 hours. Hours, right? 3. 120 plus 50, $170. Don't forget your units. Your units on final answers. Mom is pretty good to you about providing units, but if it's like a on paper problem, you've got to write the units in yourself. And I might see this kind of problem saying the cost is 40 per hour plus $50 or something, where the letters they request might be applied to the context of the problem. Right? Final cost based on the number of hours worked. Okay. Obviously, I've changed gears here. I'm kind of talking about some applications right now. Here's an interesting one. I kind of like it because it's a true fact kind of science question. All right. There's a certain kind of cricket out there. And this equation describes the temperature in Fahrenheit. Based on the number of chirps. If you went outside and listened, cheep, 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 and counted them, the number of chirps per minute, right? The number of chirps per minute. You could count all those chirps in a minute. You could figure out the temperature outside. Because this particular cricket is very consistent, I guess, but in reality, they all do this. They slow down when it gets cold and they speed up when it gets warm. So if I hear 120 chirps, in that minute, what's the temperature? All right, I count 120 chirps in that minute. What's the temperature outside? This equation models that situation for me. All right, I got this number I'm supposed to use. Where does it go? Chirps per minute. The final temperature is based on the number of chirps. How about N for number? Huh? This 120 would go in there. All right. The temperature is 1/4 times the 120. And for some reason, there's always this baseline 40. Yeah, I did 40. So how about it's 70 degrees out? Not anymore. Not right now. Very typical kind of follow-up question for an application problem. We've got an equation, maybe you've had to develop it like that last one I did about the workman. But now that you've got it, and he worked for 3 hours, you know how much you got to pay. What does the slope mean in this equation? Now it's a fraction that makes it a little messier to talk about, perhaps. All right, see if you can remember, slope is a rate of change. Basically, it's, right, y over x. What are the units in this problem for the y values over the x values? All right. Temperature divided by chirps. All right, the temperature depends on the number of chirps per minute. So the slope describes, basically says that something like the temperature will increase 1 degree for every 4 chirps, just because it's a fraction. If this was a 1, I could say the temperature goes up 1 degree for every chirp. Well, it takes 4 chirps to get me 1. The temperature goes up for every 4 chirps. Not the easiest example, perhaps, to interpret that way. But what's the 40 mean? What's the 40 mean? Usually we think of that number in the equation as it's the y-intercept. What happens? Where are we? 40 here. All right, here's my temperature, and here's my number of chirps. What's the 40? What's happening? What are the crickets doing? Zero. It got too cold. The crickets stopped chirping. If the crickets stop chirping, then it's no warmer than 40 degrees. It's 40 degrees or less. Now this, you're not going to get negative chirps, so this is one of those situations where, you know, once it gets to 40 degrees, the model doesn't help us much. Once it gets that cold, you know, if it's 20 degrees out, you're not going to get, you know, negative chirps or something like that. But the y-intercept, think about it's when the time is 0, or when the value, the x value is 0. What's going on? The x value is 0. What is that value? The number of chirps is 0. How am I doing? About out of time here. All right. I think I will just kind of wrap that up. We'll do more of this tomorrow. All right. And as I mentioned just before we started anyway, I did just this morning post a review outline, basically, in my Open Math in the forum discussion forum for this week, week 8, 8, 9, 10, 11. We're almost there. So I encourage you maybe even to print it out for yourself and at least to open that, maybe save it on your computer or something like that as a reference document. And I'll probably just kind of start going down the list. Can you plot points? Can you do this down that list? And we'll see what we need to practice more tomorrow. I'll start reviewing tomorrow. Okay, so take a look at that, pull it out, give, you know, well, what is it, 4.3, 4, and 5 are due tonight. 4.6 we just finished. I always give you till next Monday, but you really should finish 4.6 sooner because our test is Thursday, right? Our test is Thursday this week. So get it done ahead of time, run into problems, difficulties, and ask me questions if you need to. Okay, so I'm gonna let you go, or I'm gonna go, and we'll start reviewing tomorrow. Okay? Okay. All right, folks, have a good rest of your day, and I'll see you tomorrow.
Thank you, Steve.
You're very welcome. See you.